Kia ora, Year 11. I thought I'd do a lesson on solving equations with fractions in them. Hopefully you found the last two really useful. I'm expecting that you have found that working from home is slightly different than working at school. So do find if you do get stuck, please email me, please ask for videos. I'm more than happy to help. I hope you're managing to maintain a balance, a little bit of outside time in the sun. Keep looking after yourselves. You guys are doing amazing, I'm sure. Okay, this is a fraction equation. All four of these are fraction equations, but they are uniquely different in the sense of how you might want to approach them. This one, we've got a number divided by 4 is 3. So probably the easiest thing to do is just to times by 4. If you times by 4, this side you've got a number divided by 4, then times by 4, you've just got x left over. Here, you've times by 4, so it's equal to 12. The same method would work here, timesing through by 3, and you can use that, timesing by 3, and then times by 3. You'd end up with x minus 2 is 15, and that's the right strategy. And now you've got a minus 2 is 15, a number minus 2, the opposite of minusing 2 is adding 2. So you've got x equals 17. The issue happens when you've got a number on the bottom on both sides. My recommendation, you can, if you wish, times by 4, then times by 3. And I know a lot of students do that as their strategy. My strategy instead would be to write equivalent fractions. If I times top and bottom by 3 on this side, I've got 3x plus 9 over 12. And that's equal to, times top and bottom by 4, 8x, sorry for going outside the lines, minus 4 over 12. All right. Okay, so continuing, you've now got a 12 on the bottom of both of these. If we times both sides by 12, we're only going to have 3x plus 9 divided by 12, then times by 12. You've only got the top. And that's equal to the top on this one, 8x minus 4. I'm just going to pause here and say that if you times this 3 by the top, this 4 by the top here, and got rid of the denominator, that would have been the same as timesing the whole fraction by 12. You would have got it down here anyway. Now you've got 8x minus 4 and 3x plus 9. So I'm going to minus 3x from this side, minus 3x from this side. I'm going to get 9 equals 5x minus 4. Now I just want x by itself, so I'm going to get rid of this minus 4 by adding 4. And that gives you 9. Try again. 5x minus 4 plus 4 is 5x. 9 plus 4 is 13. So if 5x equals 13, x must equal 13 over 5. Now, because 13 over 5 equals x, you can still write x equals 13 over 5, no problem. Okay, here we've divided both sides by 5. Okay, last one, I'll just pause. Okay, I've just moved the problem over here, so we've got more space. This one we've got two fractions being added. Again, I suggest writing equivalent fractions. So if we write this as 5x over 10, times in this one top and bottom by 5, plus 2x over 10 times in top and bottom by 2. Now, because we've written equivalent fractions, they're still the same, they're still equal to 7. Now we'll times through by that 10 on the bottom. So we've only got 5x plus 2x equal to 70. Now that means 7x is 70. We'll divide by 7. X equals 10. My recommendation, every time you've got fractions, try to write them as equivalent fractions and times through by the denominator. If you went back earlier in the video and we had the question that we had x over 3 equals 4, we've done the bit where we've made them equivalent fractions because we've only got one fraction. We times by the denominator. Okay, get them as equivalent fractions, then times by the denominator. Okay, hopefully that helps you. Your exercises are in the Gamma book. Okay, there's 3 exercises. Feel free to do every second or every third question. If you're getting stuck, go back and do a few more in the area that you're comfortable with, and then see if you can move on.